Hello and good evening, CTS265, Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course from the Cisco Networking Academy, and this evening's video tutorial is going to be on Discovery Activity 14, where we're going to be implementing OSPFv3. Alright, so the first step is asking us to go ahead and on router 1, it wants us to enable IPv6 Unicast routing. So we would do that by saying IPv6 Unicast routing. And before we do that, actually, let's go ahead and see what happens if we don't enable IPv6 Unicast routing and I say IPv6 router OSPF1. You can see that we receive an error message telling us that we must have IPv6 Unicast routing enabled. So the next step is going to be to go ahead and start up the IPv6 router OSPF1 section. Now that we've enabled OSPFv3, we need to go ahead and say router ID. We need to make sure we have a router ID defined for each router, or else the process is not going to start. We're not going to be able to form an adjacency with everyone. And then it says declare loopback 0 as a passive interface. So let's go ahead and say do show run interface brief. And let's see what interfaces we have. Do show, IP interface brief. Do show IP interface brief. So we've got quite a few interfaces here, but only 3 of them are up. So we're going to go ahead and say passive interface loopback 0. Alright, so let's say do show run section OSPF. So right now that's really sort of the whole of the IPv6 OSPF configuration, as you can see, but we're going to dig a little further in here. Now, one of the key things to remember is OSPF was defined, or OSPFv3 I should say, was defined in RFC, I believe 5340. Let's take a look here. I think this is the correct, OSPF for IPv6. And I'd like to see it in the editor here. So there we go. We'll pull up the PDF here. So RFC 5340 is the OSPF for IPv6, and there also have been some updates. One significant update, which I believe, I don't want to say it's not that. I think it's RFC 6969. RFC 6969 PDF. Let's take a look here. And exactly, so these are the, well, this is actually the registry update, and it updated some of the OSPFv3 registry values or the instance IDs that exist. However, I was looking for the address family edition, and I'm actually drawing a blank right now on the address family update, and let's see if it's covered in here. I believe they cover the address families, and I don't see them in here. So let me see if I can. No, it's definitely not that one, and I don't think it's 7305. No, it's not the auto configuration one either. So let's go ahead, let's do a quick peek here, and I'm not a big fan of the Yahoo search, so let's say Google, and alright, so we'll say OSPFv3 address family RFCs. 5838, there we go. Alright, so this is a fantastic RFC here. It talks about the support for address families. So we saw when we did the named mode for EIGRP that we had the address family IPv4 unicast and we had the address family IPv6 unicast. Well, with OSPF, and specifically with OSPFv3, which is OSPF for IPv6, we have much the same thing. So, and we're going to actually take a look at the address family mode as well. You can see here there were the instance IDs, and these have been updated in that other RFC. And we're going to come back to this screen here because this section right here is extremely important regarding the address family bit that gets set in the OSPFv3 options field. And if you have speakers in your OSPF network, that do not have the address family bit set. In other words, they are not address family capable and aren't running the address family mode, you're not going to be able to form an adjacency. All right, so the next thing it wants us to do is to enable OSPF for IPv6 on the active interfaces. And we already saw, if we're on router 1 here, we already saw that we have do show IP interface brief. And let's go ahead and say include up. Oh, sorry about that. All right, so we're going to be going into interface Ethernet 00, where I'm simply going to say IPv6 OSPF 1 area 0. And then we're going to go into Ethernet 01, and we're going to say IPv6 OSPF 1 area 0 there as well. And then we're going to go into interface serial 20. Now this is going to be in a different area, and let me check here. I was remembering the first two. So 00, and actually it appears that 01 is in area 2. So let me correct that. This is what I get for trying to memorize the areas. So let's see. Do show run interface Ethernet 02. I mean 01. All right, so we're going to go ahead and say no IPv6 OSPF 1 area 0, and you can see we've got some messages popping up. It says incorrect area, and that's absolutely right. So we put the wrong area on there, and so that is the log message we would expect to see, and so it should be area 2. All right, so let's make that happen. There we go. And instead of messages telling us that we've got an area mismatch for OSPFv3, what we should see is an adjacency at some point. So let's go into the loopback interface as well. So we'll say interface loopback 0, IPv6 OSPF 1 area 0. And then let's go down to the serial 20 and say IPv6 OSPF 1 area 1. And do show IPv6 OSPF interfaces. So it still seems like, and let's do the brief, still seems like we have a mismatch, and we do. Do show run. So serial 20 is in the right. Yeah, so for whatever reason it didn't change there. So interface Ethernet 01, no IPv6 OSPF 1 area 0, and we want IPv6 OSPF 1 area 2. And there we go. All right, so we've gotten the areas sorted out. We should also see that we have a neighbor on do show IPv6 OSPF Neighbors. So there are the two neighbors that we have right now, and remember we should be very familiar with this output from the OSPFv2 configuration that we've done. We have the neighbor IDs, and remember these are identified by their router ID, right? And so it's 4.4.4.4 and 3.3.3.3. Both multi-access segments, right? We've got DR, BDR election taking place. You can see that router 4 is the DR on the segment with router 1, and on the segment that router 1 shares with router 3 is the DR. We have our dead timer here, which is 40 seconds. The interface ID, which is an internal value that OSPFv3 is using. And we've got the actual outgoing local interface out which these neighbor relationships and adjacencies have been formed. Okay, so you'll notice that when we say, let me actually clear the screen here. When I was doing the do show IP interface brief, I was making the assumption that do show IP interface brief, I'm seeing the IPv4 information, but that if I were to say do show IPv6 brief, I would see that the same interfaces would be in the up state. And as you can see here, it's Ethernet 0001, excuse me, serial 20 and loopback 0. All right, so we took a look at the neighbor table. Now let's take a look at the routing table. If I say do show IPv6 route, you can see that we have learned a couple OSPF routes. If I use the OSPF keyword to trim down the output to just take a look at the OSPF information, you can see that we've learned two routes, one on coming from Ethernet 1.0 and the other one through Ethernet 0.0. You can see that the cost is 11, telling us that it's probably a loopback interface for a default cost of 10 and then a hop count or a cost of 1 for the loopback. And we've got the administrative distance. So OSPF's administrative distance does not change based on the version of OSPF. So the administrative distance is still going to be 110. And as you can see here, how are the link local addresses? And again, the neighbor adjacencies are formed via the link local addresses. They are not formed using global unicast addresses. So we can clearly see here that these are EUI 64 generated link local addresses. Okay, so what we're going to do now is we're going to make this a little more readable. So it's asking us to take a look on router 1. Excuse me. If I were to say, again, do show IPv6 interface brief, you can see that the link local addresses here are the EUI 64 format, a little difficult to decipher which interface or which link local address corresponds to this router. So let's jump into Ethernet 0.0, and we're just going to say IPv6 address FE80::1 link local. We're going to go into Ethernet 0.1. We're going to say the same thing. We're going to go into interface serial 2.0, and we're going to say the same thing. So now if we were to come back and say do show IPv6 interface brief, now we've got some link local addresses that make a little bit more sense. The loopback address I'm not too concerned with, but we'll go ahead and for completeness we'll get that one as well. Because again, remember that the interface, it does not have to have a global unicast address, but it does have to have a link local address. All right, and so there are the link local addresses that we have now. Excuse me. So you'll notice that we don't have a neighbor relationship with router 2. So, and if we take a look here, we have an NBMA, non-broadcast multi-access frame relay network here that's going out serial 2.0 that's connecting to router 2. So now the question is, why is router 1 not able to form an adjacency with router 2? And the answer is because of the fact that this is a non-broadcast multi-access link. So, excuse me, in a DMVPN scenario, we could be faced with the very same challenge, and that is for adjacencies that are going to go over non-broadcast multi-access links, we need to make sure that the connectivity between the link locals and the global unicast addresses has been established, right? And in some cases, you actually have to do a static mapping of the neighbor statement that's going to point to the link local address, because again, this is a non-broadcast multi-access segment. So on router 1, what I'm going to have to do is I'm going to have to actually define, statically define the neighbor router 2. And we've already seen that it's FE80::2 is the IP address here on router 2. So on router 1, in order to bring that adjacency up, I'm going to go ahead and go back into the interface serial 2.0. Whoops, sorry about that. Interface serial 2.0, and we're going to say IPv6 OSPF neighbor FE80::2. And what this is doing is this is creating a static mapping from router 1 to router 2. So if I say do show IPv6 OSPF neighbor, excuse me, and there we go. Came up a little late. But you can see that we now have the adjacency established between router 1 and router 2. So now if I say do show IPv6 route OSPF, I should see far more routes, because router 2 has a substantial number of loopback addresses that we're going to be dealing with here shortly. And so again, over those non-broadcast multi-access links, where and again, similar to DMVPN, which is an NBMA style network, we may have to make static assignments of the neighbors in order to get those adjacencies to come up. So now let me go ahead and say do show run int serial 20, and you'll see that the encapsulation is frame relay. You'll see that we have the global unicast address as well as the link local address, and then we have our IPv6 OSPF neighbor statement. You can see here that we've got static frame relay statements enabling the broadcast capability as well in order to bring up the frame relay connectivity. All right, so on R1 we'll say do show IPv6 OSPF database. And you'll see that the database looks much the same. However, we've got some new LSA types, and we're going to stop and take a look at those. So with IPv6 or OSPF v3, we've got two new LSA types, or I should say two new LSA names, but it's still type 3, right? And if you think about it, the name actually makes quite a bit of sense. So this is the inter-area prefix, right? So before, where it was just simply the summary prefix, right, or the summary type 3 summary LSA, now it's called an inter-area prefix, and it makes sense because the summary LSAs, the type 3s, are inter-area, and it's a prefix, right? So inter-area prefix LSAs are going to be the new name for the type 3 LSAs in OSPF v3, and then, and let's see if we have the entry down here, we have a new type 8 as well. And so, excuse me, the name of the type 8 is the link LSA. Now, with legacy OSPF v2, right, or so OSPF for IPv4, the type 1 and the type 2 LSAs contained all of the addressing information. So if for whatever reason you had any kind of a change in the network that precipitated a change of address, that would cause a reflooding of the type 1 LSA, and more importantly, it would cause a full run of the SPF algorithm. So, because whenever any type 1 or type 2 LSA were to change, that would trigger a full SPF run. So, lesson learned, the OSPF v3 implementers extracted all of the addressing information when they came up with the blueprint for OSPF v3, and now the addressing information is carried in the type 8 and the type 9 LSAs. And so again, excuse me, the type 8 is just called the link LSA. The type 9 is called the intra-area prefix state LSA, right? So this is the type 8, and I guess this is pretty long, so they didn't put type 9 in here. But there's your type 8, and here is your type 9. Now, a couple of key things, right? So the type 8 link states are local to the link. So the flooding scope of a type 8 LSA is limited to the link that LSA is on. So in other words, you're not going to find a type 8 LSA being flooded into different areas, and from area 1 to area 3 and area 0. So it's not going to be flooded into different areas. It's local to the link. And then the type 9 LSA, right, is where you're going to end up with, or typically, a router can keep, or I should say originate, intra-area prefix LSAs for a router or a transit network. And so the link state IDs, and actually the link state IDs for both of these guys are the router IDs, right? Are the router IDs. As you can see right here, the 1.1.1.1 and the 4.4.4.4. All right, so those are sort of the new LSAs, or I should say 3 of the new LSAs. What we haven't seen is the renaming of the Type 4, which was the ASBR summary. That's called an inter-area router LSA, but we haven't seen that yet. We're probably going to see that in one of the upcoming labs. All right, so we've already taken a look at the routing table. We've got a decent sized config here. So now what we're going to do is we're going to auto-magically convert this config into the OSPFv3 for address families. And this is always sort of a challenging area for new learners, right? So when we talked about EIGRP, right? So I'd like to compare and contrast. We said that you had EIGRP v4, which was IPv4 only, right? And the transport was IPv4. And then you had EIGRP v6, which was for IPv6, and the transport, let's put trans, is IPv6. And then you had named mode, which had address families for IPv4 and IPv6, and the transport was the respective protocol. So the transport for v4 was v4, was v4, and the transport for IPv6 was IPv6. Now, over on this side, when we talk about OSPF, we've got OSPFv2, and this is the one that you'll be familiar with from your studies, your CCNA studies. And this was IPv4, right? And then we had OSPFv3, and the transport, it's for IPv6, and let me put down here the transport is IPv6. And OSPFv2, the transport was IPv4, right? Now, with RFC 53 or 5838, right? So we'll say RFC 5838, we had OSPF v3 with address family support. And so now we can support address families just like we did with named mode over here. We have an address family for IPv4 and we have an address family for IPv6. However, there is one significant difference. The transport is IPv6 for both address families. And so let me say that again. The transport for OSPF v2, which was IPv4, OSPF with IPv4, the transport was IPv4. OSPF v3, which was OSPF for IPv6, the transport was IPv6. So we needed to have IPv6 addresses assigned everywhere. The transport for OSPF v3, and again, it's the same OSPF, right? This is OSPF v3. It's the same OSPF. It's just that this RFC implemented address families within OSPF v3. Now, all the configuration commands are a little bit different, and we're going to see that. You're going to be actually saying OSPF v3. And the key thing to remember is that the transport is IPv6. And so you need to have IPv6 configured everywhere. And the other important note is the AF bit. And we referred to that AF bit earlier in the RFC. And it's the address family bit. And it's put into the header. And if you're trying to communicate with a router that is not capable of supporting address families, right? Or an OSPF process, I should say, that can't support address families, and it does not have the AF bit set, you're not going to get an adjacency established. Now, another key factor here is that I can actually set this up over pure IPv6 addressing. However, the address family for IPv4, I cannot establish an adjacency with a legacy OSPF setup over here, which would be OSPFv2 for IPv4. These two are incompatible, 100% incompatible. So let me go ahead and come back into the window here and get back on track. So what we're going to do now is we're simply going to convert this do show run section OSPF, this OSPFv3 configuration that we have, which starts here at the IPv6 router OSPF1. And you can see we have just a couple of statements here. We can actually sort of auto-magically convert this into OSPFv3 for address families. So if I were to say, let me exit out one here, if I were to say router OSPFv3 and then use the same process ID number that we've already used, watch what happens. Now you'll notice I don't receive any notification about anything happening at all. But now when I say do show run section OSPF, take a look at that. The original OSPF section is gone. And it's auto-magically converted my configuration into the OSPFv3 address family mode configuration. And so it does look a little bit different, but it should look familiar because, again, this is very similar to the EIGRP named mode. Now, again, we didn't actually drop the adjacency. You'll notice that it did this, and it was absolutely hitless. So if I were to say do show IPv6 route, you can see that I still have all my routing information. Do show IPv6 OSPF Neighbors. You can see that I still have all my neighbor relationships, and the dead times they're not on the countdown to extinction here. So again, it was absolutely hitless, and we were able to make that conversion. Now, I had commented that the commands change a little bit. So you notice I typed in show IPv6 OSPF neighbor or show IPv6 route. If I were to say do show IP route, and actually let me back out of here real quick so we can get the context sensitive. So if I said show IP route, I want you to see that there is an option here now for OSPFv3. So if I say show IP route OSPFv3, it doesn't show me anything. However, when we come back, when we start to talk about the IPv4 address family, this command will become important. So I can say show IPv6 route, and you'll notice there's no OSPFv3 here because this command will already show me all of the OSPF routing information. Now, remember we used to say show show IPv6 OSPF Database, right? So that's one way to do it. Now with the new address family mode, you can also say show OSPFv3 Database, and this is going to show me the database as well, right? So again, it's just some new commands, and again, very similar to the command changes anyway, similar to BGP, which we get into here in a couple of weeks, where instead of saying show IP BGP, you're going to start using the address family, the AFI and the SAFI, in other words, the address family identifier and the subsequent address family identifier, in order to execute commands. So instead of saying show IP BGP summary, you're going to end up saying show BGP IPv4 summary, because again, you're going to start to narrow things down to the specific address family that you're interested in looking at. And the same thing goes for when I did the show IPv6 OSPF neighbor. I could say show OSPFv3, and let me do a question mark here. Sorry about that. I keep misspelling OSPF. OSPFv3 with a question mark. So I mean, take a look at the show commands for OSPFv3. We could take a look at the process. We could take a look at the database, the events, interfaces, neighbors, statistics, Again, quite a few options here that we can look at. So let's say show OSPFv3 database like we just did. We could say show OSPF statistic, right? So here are some of the shortest path first calculations. What are some other options that were there? Neighbor, right? So very similar to show IPv6 neighbor, correct? Or I'm sorry, show IPv6 OSPF neighbor. There we go. So again, just a different way to run the commands, right? All right, so now it's asking us to change on the interfaces using the new configuration approach, right? So you'll notice that the old configuration approach, when I say do show run interface, we'll go Ethernet 00, or I'm sorry, show run interface Ethernet 00. You can see that we've kind of got the old OSPF, or let me call it the non-address family mode activation method here. Now remember, with OSPF for IPv4, OSPFv2, I could go into the interface and say IP OSPF1 area 0. With IPv6 or OSPFv3 for IPv6, you have to come under the interface because there's no network statement, right? And again, this is very similar to EIGRP v6, not named mode, but EIGRP v6, where there's no more network commands. You had to go under the interface. Now, the difference between the named mode of EIGRP and the OSPFv3 address family mode is that with the OSPFv3 address family mode, we still need to go under the interface. However, we can do it in a non-impactful way. So if I were to say interface loopback 0, the new way to say it is just simply OSPFv3 and then the process ID number, which is 1, IPv6, and then whatever area that's supposed to be in. So now when we go back and take a look at, let's say, do show run int loopback 0, you can see now that that is the new way the OSPFv3 address family syntax to put under the interface. And so again, if you're converting, you'll notice that, and let's actually do this on the serial 20 interface, and let's make sure that when you run that command, so OSPFv3 1, IPv6 area, and let's remember the serial 2 interface was, I think, area 1? Yes, area 1. So I'm going to go ahead and back up here and say area 1. Let's see if it's hitless. You'll notice that we didn't see anything go wrong with the adjacency. The adjacency didn't reset. So do show OSPFv3 neighbors. And there we go, right? So we've got all of our neighbor adjacencies, and it was absolutely hitless. So as you can see, to convert your configuration from the OSPFv3 non-address family mode to the OSPFv3 address family mode, it's going to work. And the other thing that we should notice is that OSPFv3 non-address family mode works perfectly fine with OSPFv3 address family mode. So look at the diagram here. If I were to go take a look at router 4, and let's go ahead and see show run, let's do section OSPF. And we've got the address family mode there. Let me check on router 2. Show run section OSPF. I'm hoping these are address. Let me guess, these are all going to be address family. Show run section OSPF. So looks like router 3 has nothing. That can't be right. Hold on one second. Show run section OSPF. There we go. All right, so these are the address family. So I guess it's in the reverse order as the way I'll describe it. Is when we first configured router 1, we configured with the non-address family OSPFv3 mode. And it worked great, right? We had adjacencies up with everybody, router 2, 3, and 4. Now we've decided we're going to go ahead and convert it to address family mode. And I think I still have one interface left here. Let's say Ethernet interface 01, and that was in area 2. It'll go down if it wasn't in area 2. All right. And so again, this is sort of the preferred way to do the configuration, right? Is to update all of your OSPFv3 address family mode configuration areas with sort of what we'll refer to as the proper syntax. Okay, so we've walked through and we've done that on all of the interfaces. Let's see. For those of you following along, I'm actually on step 12 at this point. And now what it's asking us to do, and this is where it's going to get interesting, right? It's asking us to enable the OSPFv3 process for the address family IPv4 unicast. Now remember, the transport that's being used is IPv6. So in effect, what you really have happening is it's almost as if OSPFv3 with address family mode, it's almost like a routing application at this point that just basically is riding on the back of IPv6, right? So let's go ahead and jump into interface loopback 0. And remember before where we were saying OSPFv3 1 IPv6. Now I'm just simply going to say OSPFv3 1 IPv4 area 0. And we'll do the same thing for Ethernet 00, which is, I'm pretty sure that was area 0. And then Ethernet interface Ethernet 01 was area 2. And then we had interface serial 20, which was area 1. Now, take a look at that. We've got our OSPFv3 adjacencies for the IPv4 address family. All right, sorry for the little interruption there. So yeah, I've got got some additional credits here. So we're going to go ahead and we'll finish this up. So I've gone ahead and we left off on interface serial 20. And if I were to say do show run int interface serial 20, here's what we see. Now again, we're going to need the same neighbor statement, but we're going to put it in. It's going to be OSPFv3 1 for the process ID 1, IPv4 neighbor FE80::2. Now, this is a huge sign right here that IPv6 is our transport, because the adjacency, even though it's the IPv4 address family, we're establishing the adjacency, right, over IPv6. Okay? So again, the IPv4 routing information is just being sent throughout our network via the IPv6 transport, which is why you don't see us referring to an IPv4 address here, because remember, OSPFv3 with address families can only work with a transport of IPv6. So I go ahead and I'll put the IPv4 neighbor statement in there for FE80::2, and then let's now jump back into router OSPFv3 1, and I'm going to say address family IPv4 unicast, just like EIGRP, right? I'll say passive interface loopback 0, and you can see the neighbor has come up there now that we've added in that static neighbor mapping to make it more of a unicast mapping as opposed to the multicast on the FFO2 FFO2::5. All right, so everything has come back up now, and everything looks good to go. Let's do some validation here. So if I were to say show OSPFv3 neighbors, right now, and this is really nice output here. So running the one command, right? I don't have to say show IP OSPFv3 IPv4 neighbors or IPv6 neighbors. I can just say show OSPFv3 neighbors, and here you go. So OSPFv3 1 for my IPv4 address family, and then right here is my IPv6 address family information. So you can see that we've established the adjacencies for both OSPFv4 and v6. And who are we missing here? I actually reran this from, I had to set this back up after getting the additional credits. So let's say show run section, or actually show run interface serial 20. And let's see if we are missing. Yes, we need to convert. Do you see the issue? Who sees the issue? So I still have my legacy neighbor mapping statement here. However, what I will need to do is let's go ahead, let's convert that statement to the new form. And we'll go into global config here. We'll say interface serial 20, and I'm just simply going to say OSPFv3 1 IPv6 neighbor. And let's see if this : 2. Let's see if this resolves the issue there. So do show run interface serial 20. All right, so we now, and let's take out the no IPv6 OSPF neighbor. There we go, and that's what we needed. And I'll take out that legacy statement there. So let's confirm one more time. All right, so we've got that single statement in there now, which is basically statically defining the neighbor. So now we can pick back up where we left off. If I say show OSPFv3 neighbor, there we go. So now we've got all of our adjacencies are back. We can take a look at the routing table. So show OSPFv3, or show IP route actually, show IP route OSPFv3. And so this is going to show me the IPv4 routing. If remember before, I ran this command intentionally before when I said show IP route. So if I say show IP route, you can see that I do see the IPv4 routing information. What happens if I say show IP route OSPF? Nothing, right? Because again, we're running OSPFv3. Totally separate control plane, totally separate transport than legacy OSPFv2. So there is my IPv4 routing information. So do I have reachability? Let's see, 192.168.2.2. I do. Let's check 3.3. And I do. Everything looks great, right? So again, in order to see the information, I say show IP route. If I want to limit it to the OSPF, and I'm running OSPFv3 with address families, I have to say show IP route OSPFv3. I can't say show IP route OSPF, right? It's going to leave me with nothing. All right, now let's go ahead and take a look at some of the LSAs, right? So if I say show IPv6, or actually you could say show OSPFv3 database, right? Let's see what the router LSAs look like. So here's the router LSA, or router LSAs, right? We've got the router LSA for router 1, for router 4. You can see the DR information, the DR router ID. So if we take a look at network, so here are the type 2 LSAs. And again, the addressing information has been removed and it's been put into the type 8 and type 9s. And as you can see right here, the AF bit is set, right? And that is the address family bit that is being set in the options area in the OSPF LSAs. And so this is where the AF bit gets set. You'll notice that this is totally new to us, right? We haven't seen this until we enabled OSPFv3 with the address family mode, and now the AF bit is getting set. Okay, let's clear the screen here. Let's take a look at the new. So we'll say show IP OSPF database, and as you can see, we've got the inner area. Whoops. Inner area for the prefix, right? So here's my inner area for the prefix LSA, and you can see what information is now in here. The addressing information. Again, the addressing information has been removed from the type 1 and type 2 LSAs, and it's now in the type 8 and type 9 LSAs. So the inner area prefixes are type 9. Let's go ahead and take a look at the the intra area. Or the link, I should say. Take a look at the link. So here's my type 8 LSA. And again, what do we see here? Here is all of the addressing information. Link local address, the prefix address, right? So all of the information, the addressing information, has been pulled out. And again, you can see that the AF bit has been set. Okay, so we've done the conversion. Let's go ahead and say, let's do the old school, show IPv6 route OSPF. And again, there's all of our OSPF routes. Let's see if they're... Yeah, so step 17 says configure area 2 to act as a totally stubby IPv6 area, or totally stubby area for IPv6. So area 2 is going to be, so we're going to be doing this between router 1 and router 3. So let's hop on router 1 here, and this is going to be pretty straightforward. So we'll go to global config and say router OSPFv3 1 address family IPv6 Unicast. Remember, we're doing this for IPv6, and it's identical to, when we configure this as a totally stubby area. It's the same configuration commands that we used when we were doing OSPFv2 and I shouldn't say the legacy, but the OSPFv3 non-address family mode, where I simply say area 2 stub no summary. Now this is going to tear the adjacency down, and there it goes with router 3. So let's cruise over to router 3 now, and we're going to do the exact same thing with the exception of that no summary argument. We're going to say router OSPFv3 1 and address family IPv6 Unicast. Remember, we're doing this for IPv6. And I'm simply going to say area 2 stub. Now, I can say stub no summary, and I've talked about this in previous videos. I could say stub no summary. However, there's no need for me to say that because it's at the ABR where that matters. So, and you can see the dead timer expired there. So I'm going to hit enter, and now the adjacency is going to auto-magically come back up for us because now the stub flag, they match in the hello packets. And so as you can see there, the adjacency just went from loading to full after transitioning through the state machine, right? It was down, init, ex start, exchange, I'm sorry, two-way, I left the two-way out, and then loading, and then to full. Excuse me. So now let's go ahead on router 3 and say show IPv6, or do show IPv6 route. And you can see we are no longer receiving, and we don't have all of the routing information that we previously had. What we've got is simply a default route, right? Whoops, sorry about that. We simply have that default route, inter-area default route. Let me get the pen up here. Inter-area default route, and it's going to be through router 1, and this is why we changed that link local address, and out my local Ethernet 01 port. And so again, the totally stub says not only am I not going to accept, or I should say, I'm just simply not going to be taking in any inner area type 3 LSAs with the exception of the default route, which is automatically provided to me. Because if we take a look at the drawing here, we take a look at our diagram, you can see that from router 3's perspective, how can router 3 get out of the network? There's only one way for router 3 to get out of this area, and that is through router 1. And it's the same thing here for router 2. You know, it makes a ton of sense to make router 3, or to make this area, to make area 2, a totally stub area. Because router 3 doesn't have some sort of an optional path to get out, maybe over here to router 9 or something like that. He's got one way out of the network. And when you've only got one way out, router 3 is not going to need the entire routing table from this OSPF domain in order to successfully route his traffic. He just needs to get the traffic to the ABR, who is going to be router 1. And then router 1 will take care of the heavy lifting. All right, and so the last thing we're asked to do is summarize these addresses here. Now, I know when you're looking at this, you're thinking to yourself, holy Toledo, that is a lot of addresses to summarize. However, when you look closely, you can see that these 16 addresses here, it is that little hex character in the 4th hextet that we're concerned about. So we've got 16 bits there, 16 bits there, 16 bits here, right? Remember, rule of zeros is allowing us to do that. And then we've got 0, 2, 2, so 12 bits there. So it's only these 4 bits that we would really be concerned about. And so we know that 0 is 0, 0, 0, 0, 1, 0, 0, 0, 1, 2, and then 3, and then 4, and then 5, and then 6, and then 7. I'm writing larger here each time. And there's 7, and then 8, 9, 10, 11, 12, 13, 14, and 15. And so when we take a look at this, where do they no longer match? Well, yeah, they stop matching right there anyway, right? Because you can see we've got a whole bunch of 1s here and then a whole bunch of 0s in the high order bit of this nibble, right? These 4 bits, which is half of a byte, a nibble. And so then we can easily deduce that it's 16 plus 16 is 32, 48, and then 60. So we've got a /60 on our hands, and we know that the last bit value here was a 2, so we're going to hold on to that. So what it would look like is it's going to be 2001, I'll give myself plenty of room here, DB8, colon, and I'll put the 0 back in there, colon, and it's just going to be 220, colon, colon, /60. So that is our IPv6 summary. And again, this looked pretty menacing initially, but not so much. Okay, so that is the summary that we're going to use, and we're going to use that on router 1 because we want to summarize going into or we want to summarize the routes being advertised by router 2. And we're going to do that. And where do we have to do that? So this is a good question. Where does that have to be done? Well, it has to be done in OSPF at the ABR. Because remember, I can't just simply decide to summarize right here for whatever reason, or to come down and summarize right here for whatever reason. I need to make sure that I summarize at the ABR so that the link state database, right, is identical throughout the areas, within each area that it's identical. And so I've got to do that summarization here at the ABR. Now remember, if we had an ASBR maybe hanging out here somewhere, right, and it was injecting routes in, for that we would do the summary for the external routing information at the ASBR with that summary address command, just like EIGRP, right? However, at the ABR, this is where we're going to use that area range command. And don't let me forget I put a 1 in here, so area 1, the area that we're going to be doing the summary for, and that is area 1. All right, so let's go ahead. I'm going to clear the screen here. And again, it's really easy enough to say that is the summary that we're going to be using. So let's clear the screen. Let me come on to router 1 here, and let's go ahead and knock out this summary. So I'm already in the, I'm not sure, so address family IPv6 Unicast, and I'm simply going to say area 1 range, and we'll put the range in here, 2001 DB8 colon 0 colon 220 colon /60. All right, so now I've done the summary here, so let's go see what router 4 sees. And I say show we'll do this, show OSPFv3 route, or show IP, well no, actually, show OSPFv3, or actually show IPv6 route, sorry about that. So show IPv6 route, so we should see that we have, and where is it at? Where is my, there it is right down here. The inter-area summary, right, our /60 that we're learning on our Ethernet 00 interface. So if I was to go ahead and take a look at the OSPF database and say show OSPFv3 database and summary to take a look at the inter-area actually. Got to transition to those names. Inter-area prefix. So there we go. So let's go ahead and take a look here. We should find, and that was for our address family. Initially, that was for the address family for IPv4, right? Because remember, all of the information is in the same process and same control plane. So here's my OSPFv3 information. Let's see where that 220 and advertising routers, router 1, and the prefix is prefix link. It's the very last one right here. It's going from top to bottom. So here is the LSA, and the most important thing is that the routing bit is set on that LSA. This is an inter-area prefix LSA, so it has to be OSPFv3 because the inter-area prefix, right? Now, it doesn't have to be address family implemented, right? It can be non-address family OSPFv3 because this is an IPv6 invention here. This is for IPv6. So whether I was doing OSPFv3 or OSPFv3 with address families, it's still called the inter-area prefix, and all that is it's my type 3 LSA, right? You can see we've got the advertising router, who is the ABR, okay, because that's where we did the summary. Even though we're summarizing routes that are coming from area 2, even with OSPFv3 for IPv6, it still has distance vector behavior where the ABR is saying just recurse to me, and then I'll go ahead and get the traffic out to the proper area where it's supposed to go. You don't need to know what's going on over in area, I believe it was area 2. Okay, so that is going to wrap, or area 1 was where it was at. So that's going to wrap up this activity for OSPFv3. So we took a look at OSPFv3 non-address family mode. Then we looked at OSPFv3 with address family mode. Took a look at some of the differences. Remember, the significant difference is that OSPFv3 with address family mode activated, it's going to have the AF bit set, right? The address family bit is going to be set, and it will not work with non-address family routers. And in fact, let me take a quick look here on the show run section, OSPF. So as you can see here, we've got on router 4, the Ethernet 00. So if I were to come here to router 4 and go into global config and say no router OSPFv3 1, I just wiped out the config, right? So all of my adjacencies have gone down. The v6 adjacency went down, and so did the v4. And now I say router OSPF1. I keep misspelling OSPF, sorry about that. OSPF1. I'll set my router ID to 4.4.4.4, and I'm going to go ahead and say passive interface loopback 0. I'm going to go into interface loopback 0 and say IP OSPF1 area 0, and we're going to go into interface Ethernet 00 and say IP OSPF1 area 0. So now I've set do show run section OSPF, I've set the router back up, and I have the proper network statement there, right? Or I should say network statement, the proper interface statement, IP OSPF 1 area 0. However, the address family bit is not set. So let's check and see if I say debug IP OSPF, maybe it's under capability, advertisements. Let's see if that is where. And I'm also going to do the hellos. And adjacency. All right, so we're sending hellos. Let's see if it reports back that we are receiving any hellos. And we're not, right? Because again, the transport is what? It's IPv4. Let's come back over here to router 1, where we've got the transport of IPv6, and I'm going to say debug IPv6, or let's actually, I think you can do OSPFv3. Yeah, OSPFv3 hello. And we'll take a look at the output here, and you can clearly see, and let me go ahead and kill this real quick. Hold on one second. And you can clearly see that the hello packets are being sent to which address? They're being sent to the IPv6 multicast address, FFO2::5, right? And you can see it right here, sending hello, and then it was receiving hellos. But again, how is it identifying the neighbor? With the IPv6 address. It's just that the IPv4 routing information, the NLRI, the network layer reachability information, is being transported using IPv6. And remember, this is OSPFv3 with address family mode. So even though I can do IPv4 OSPF routing information, have it exchanged, it's going over IPv6. Again, it's more of OSPF sort of acting like an application, routing application, than a routing protocol, because it's using IPv6 as the transport. All right, so now this definitely wraps up discovery activity number 14, implementing OSPFv3. I hope that this has clarified some of the OSPF work we've been doing in class, and I will see you on Monday.